Hi, this is Mahesh Kosuri. Yeah, here we are going to discuss of DataSphere, Data Warehouse Cloud. Okay, SAP launched a new product into the market. I guess it is almost like 3 years back as Data Warehouse Cloud that will help the customers or clients to maintain their data in the cloud level. And the last year they renamed it as the DataSphere. DataSphere and Data Warehouse Cloud both are same. Both are same, and it is the cloud platform to maintain your customer data. Okay, here what is the cloud first of all? And again, here I am telling you this is for very basic introduction to the cloud and the data warehouse. This is for freshers who are interested to come into the SAP industry as a consultant or a developer. Okay, what is the space? What is the cloud management? First of all, we have to understand what is the cloud and what is the data warehouse, and then we can discuss what are the functionalities SAP has provided in this DataSphere software. First, let us discuss cloud management. Cloud management in the sense space management. Let us discuss. Here is the here you see the left side, the almost bottom side. You can see one space management. This is the basic setting for our DataSphere tool. Here you can see space management. Once I click on the space management, system is taking to space management window. Here it is showing disk for storage 2.1 MB, memory for storage 1.7 MB, and here it is showing currently one user and some connections and some settings it is showing. This is the user. So this user has been allocated this much of storage here. Can I increase the storage? No, not possible. As this is the trial version. Trial account this is. Okay, so that's why I cannot increase the space for here. But as I said before, proceeding of understanding the data sphere, what is the space management here? Here, space management just it deals with the memory allocation or space allocation for the each segment or each functionality. Say, suppose you have a Gmail account. Suppose Google, what they do, they provide default memory, default disk space for you to maintain your Gmail accounts. It's like default 15 GB they will assign you, right? So this 15 GB you can use either to store your photos or some media files, or you can use for your Google Drive, whatever the Google products are there, you can utilize your 15 GB. Not only for the emails, for other products also you can utilize your GB, that is for free. Once your GB is over, then Google will start to send alerts that your GB is going to be over, increase your space. Keep on, you may get the emails. Or else you have to clean up your space, then maintain the enough space to receive your emails and to send the emails or to store photos or library files. So this is how generally the space will Google Space also will work. The same way here DataSphere also, the space management will deal with the how much of space you use for each segment. As you know, this is the data warehouse system, right? So this is the data warehouse is nothing but ERP system, we can say simply, or OLAP system, online analytical processing system, we can say. So any, if you take any ERP system, generally what happens, you can see the different business functionalities in any business, like sales you can see, finance you can see, manufacturing, purchase department will be there, and production department will be there, right? So like this, you can classify, or you can categorize your business segments. I mean business departments. So all the departments, if you combine, then that becomes one business unit, right? So generally, when you go to any business unit, you can see different departments. Say suppose you may have some, as I said, like you may have some finance department, and you can have sales department, sales, and you may have some purchase, and you may have manufacturing. It all depends on your business type. Manufacturing, let us assume. So now, once you take the data sphere, the customer, if they purchase the data sphere, they may require, they calculate how much of GB they require. Say suppose 100 GB they require. How they calculate their, so the finance may be 15 GB, sales may be 50 GB, purchase department may be 30 GB. So what is the total? 15. Is it? So 15. So total it is like almost like 110. This much of GB required for them, right? So this much of GB they require. So once they take the data sphere, here they maintain, okay, for me, if it is the finance department, assign 15 GB, my sales department assign 50 GB, and other departments you can see the like 30 GB and 50 GB, like that you can assign. So like that you can maintain your space management for each functionality, each department 15, like that. Okay. So that's how the space management will work. If you want to increase the space, then you can raise the request for this with SAP, and they will charge something for the GB, and they will increase the space. So that's how this space management will work. And here you can see the space management, space ID, space name, everything. You can see deployment status, it is deployed. Space type is the data sphere. Space storage, I cannot enable the space quota here. Okay. Translation, it is okay. Workload load management and users. In this space, uh, how many users you want to maintain. Currently, I do not have access. I'm not because this is the trial version, so I cannot show you the users, how to add the users, those things here. And database access, what are the databases I can access by creating the users, and for each database, who are the users are there. So that's why we can maintain all the database access users and their HDI containers, HANA deployment infrastructure containers we can maintain, and you can see some edit connections also. connections also you can maintain in the space management, like this space what connections they can use. If you go to the connections here, it will show you all the list of the connections. There are some connections they have already available here, so if they are active you can connect all these either sorry all these connections you can connect, and you can bring the data from the source systems into your space management. You can maintain the connections by selecting these are the things. So like that we can maintain our space management. So in the data sphere, the very first thing is space management. That is very important thing because of course this is mostly maintained by the data sphere administrators. They will provide the how much they will estimate how much of space is required for each department, and they will create the workload management and configurations they will take care of. And the users also they will create in each department who are the users are there, so what are the database access they require. So everything the space management administrator will take care of these actions. Okay, here this is what the space management. Okay, now let us understand what are the functionalities are there in the I mean in the data sphere. As I said, like here you can see the connections and data integration monitor, data builder, and business builder, semantic onboarding, data marketplace, catalog, repository explorator, and of course home. Let me take to the home page. So this is the home page for the data sphere. Once you connect to your data sphere, first it will show you and your as a data builder what are the things you have deployed, and your spaces, what is the space you have, and what is its priority, what is current storage, whether it is working or not, status it will show. And okay, these are the things you can see. Business builder, data builder, and business builder you can see here. Okay, now before discussing of these objects, first let us understand what is the data warehouse. Okay, so the data warehouse itself is telling that it is the warehousing of the or keeping the data at particular place. But how do we keep our data into the particular place or into the storage? The very basic functionality is your database. Your data is stored into the tables, like whether you follow the star schema or Snowflake schema or extended star schema. Generally, we say extended star schema or Snowflake schema. If you are well aware of these two things, you can skip to watch this video, or else please continue to watch this video. Okay. Here I am taking off some daily wise sales data I am taking to explain what is the star schema, what is the Snowflake schema. Here I am taking some data, dummy data here I am taking. You can see some columns are here, right? Assume this itself is the data. Okay. Before talking of this data warehouse, let us go back to our childhood days when were going to the school. There every day they take the attendance in the classroom, right? So our teachers, what this do, they maintain our our one page. They dedicate for one uh, yeah, one page they dedicate for student name and roll number, and another page they dedicate for the attendance, right? And they put all the dates, like one, like this. They put all the dates. So, and at the end of the month, what they do at the end of the month, just they will replace this attendance of the current month and they replace with the new sheet. The student data will be remained constant. Remain constant in the sense they won't change this student data. If any new student come, just they will add the new student. If any student will move out from the school, they will cancel that student. Okay, like that they maintain. So here we can assume there is a link between the student, and I will separate this two. So the student name and student name table and the attendance table now separated, right? Student table and attendance table now separated. So advantage is, like, you no need to repeat the student name table for every month. No need to copy the student name table every month to the new sheet. This one is constant. Just you go here and you copy the sheet. You turn this sheet for the next month. You can see the student name there itself. That's how we see this registration data. I mean, student registered data maintenance in our school days. We can assume the same thing here is also in the data warehouse. As we are talking of the business, let us discuss the same topic in the business terminology. Okay. Now I am going to the date-wise sales. Here you can see some brands are there, variants are there, entity is there, sub-regions, customer is there, sales units are there, sales price, MRP. And of course, these numbers you can see uh, like 10 to 15 columns also you can see these figures. Maybe these columns like date, brand, variant, these many only, but from the sales units onwards you can see number of numeric values in this table. If I extend like discount, profit, net margin, or other accounts, if I extend, you can see number of accounts. So what the database scientists or designers they suggested, if you maintain all this data like this in single table, reading performance will be less and writing performance also will be less. Writing in the sense every day you need to enter your transactions, right? Okay, this date, how much I have saved, so how much I have sold units, what is my sales price. Every day you need to enter the data. At the same time, every day you need to read the data also for the reporting purpose. So what they said, this table is the combination of some numeric values and some test values, right? So they thought that if entire table is having the numeric values, then the reading performance will be increased or writing performance will be increased. Now they want to maintain the numeric values in place of test test data. What they did, okay, this is my table. I want to maintain. I want to maintain uh, numeric values in place of variant test. Let us copy this variant here. Let us put here. Let me let me remove the duplicates. So these many values are there actually. Okay, these many values are there. Variant is these many values are there. So give some ID for this one. Say suppose 10001, 100, four zeros. Okay. Okay, I'm giving the numbers here. So use these numbers instead of this test. Use these numbers in your table. In this table. In the same way, in place of entity also. Suppose here you have entities you have here. I will remove the duplicates. Let us see how many entities are there. So these many entities are there. Here, let me give the other number. So for entity also I am providing the ID. The same way you can provide numbers for the customer and brand and date also. So that what happens, your entire data becomes with the numeric value. I mean entire table will show you only the numeric values, not the test. Not the test, right? But the thing is here, if I maintain the numeric values, I cannot understand what is this numeric value, which variant it is belongs to, which variant, which entity this 10001 belongs to, right? We cannot say like by looking at this one, because if we look at the test, you can understand that okay, this is the this is the variant. This is the HRV sport, this is the CRVLX, this is the Prolog Elite, like that you can understand. But if you look at the number, you cannot understand which variant it is. So what they specified, and of course, entire and another thing is, yeah, and another thing is here, if you go with the same structure, as I said, like your reading performance you need to increase, your writing performance you need to increase. That is the objective here, right? So we are going to replace all these either sub-regions or customers, entities, and everything with the numeric values. But we cannot create the numeric values. If the system creates, if the system create a numeric ID for this one, that would be good for us, right? If you have variants, suppose here four variants, so four variants I will create some ID. That's fine. But if I have thousands of variants, that is very difficult for me to maintain IDs for every variant, right? This numeric variant. So if the system generates the numeric IDs for these members, then that would be good for us, right? In generally, if you are aware of the SQL, generally when you are adding some tables, the system will propose like is it the primary key, then is it the auto increment, like that it will show, right? So the same way here is also, if the system proposes some values and system will maintain some values for each member, that would be good for us, right? Like that, we want to redesign this entire table we want to redesign. So what I'm going to do here, let us assume this table as transaction table. This entire table is our transaction table. Okay. So here I'm maintaining one transaction table. This is my transaction table. Now, if I replace all these entities and variants with the number ID, that is difficult to understand the what is the variant. So what I am doing here, just I will maintain one more table here. Here I maintain variant. I will create one more table variant. Once I maintain the variant with these values and system proposes some values, right? Now the transaction table is also having these values. Assume in place of the variant here this test, we if we replace all these values with the numbers, then this transaction table also will have the numbers. So now variant will have the numbers with the test, and transaction table will have the only these numbers. So that what I'm trying to do here, I'm trying to build the relation between variant and the transaction table. Build a relation between transaction table and variant. Here the key is suppose variant ID. This is the table. So variant ID is my key. Variant ID is my key here. So that in the same way I will build one more table. Say suppose this is sub-region, this is sub-region, and maintain connection between these two tables again. I'm pointing to the this arrow. I'm pointing to the transaction data, sub-region to the transaction table. And the customer also, let us build one more table for the customer. This is customer table. So this customer table also should point to the transaction table. And one more, let us take one more. This is the date. Date also pointing to the transaction table. So like that, and of course you can add entity also. Entity also you can add, and entity also pointing to the transaction table. So if you take this kind of structure, your transaction table is connected with different tables. It looks like a star. That is the reason here we call it as a star schema. Okay. So in the data, before learning the data warehouse or data sphere, just we need to understand what is the star schema and what is the snowflake schema or extended star schema. So that is the reason here I'm explaining what is the star schema. The basic advantage of this one, if you build the star schema with a single query, you can build the aggregated data of this one. That is the major advantage. So your data warehouse always you maintain to read the data. So your reading should be capable to show the data in the aggregate mode. Why? Because here you see the day wise here sales are there. Say suppose first month what is my sale, second month what is my sale, third month what is my sale. You should be able to see the data in the summed up values, right? Or if subregion is if the entity is USA, under the USA, if I select the north, what is my total sales units, what is my total sales price. You should be able to analyze your data if you follow the star schema. And there is one more important thing now. Okay, in this table I maintain everything, that's fine. The variant data I will maintain. But if the variant is one column only here, right? This variant is having only one column and variant ID we are maintaining. But if this variant itself is having, okay, this is what the star schema. Okay, here one more challenge database architects have been facing. That is like if the variant table here we are showing only the one column. If the variant itself is having the some other values in the sense other some other information variant. Say suppose example, this variant I want to classify like here I'm pasting the data. This is the variant, core variant, right? So this variant is this one. Here, if I say car model and color and transmission type, so there are so many properties I am assigning or so many attributes I am assigning to this variant. Car model in the sense like, say suppose sedan, SUV, or this is also SUV, suppose, and this is also SUV, let us assume. And here I'm keeping red and blue and red and blue I'm keeping. Transmission, let us maintain different segment, gas, EV I'm putting. So this is the extra information of this variant, right? So again, this table will become a big, the big size of the uh, table, right? So what the database architects they proposed, okay, you keep your primary key here. Let us break this table into one more table. You keep this key here. This one is the constant, right? These properties may be changed. This is the constant in the sense, okay, they maintain this member id like hrvlx. This one they can maintain for many years, suppose. But sometimes they may withdraw the sedan. They can add some other model, and they can change the color, they can change the transmission also. This year they may maintain hybrid. Tomorrow they withdraw this hybrid, and they can have only the gas. So these values can be changed. These property values or attributes can be changed, but it remains constant. So whatever the values are changeable, they suggested to separate them from the master key table. So that is the reason here this one I can say this is the key table. I call it as the key table. This is the master key. I generally call it as master key. This one is the constant for me. This table is constant for me. And this is extended to the master. PK, here I am naming it as PK. So here I am establishing a connection between these two tables. Right? This PK and this PK has been connected. This is the foreign key actually in this table. We can assume. Right? So now this key, this is the key already there, right? This key is already here in this table, and this information I have separated. See, the star schema now extended. That's why we call it as the extended star schema or snowflake schema. Whatever the values are changeable frequently, those tables you separate from the master key. That is the logic behind this extended star schema and star schema. Initially, they proposed the star schema. Here, they expected that, okay, let us maintain the master and attributes in the single table, transaction data at one table, and maintain one primary key in the master table. That one you make it as the foreign key in the transaction table. Later, when they found that these properties also frequently changeable, then let us separate this properties table from the master key. Then they started to call it as snowflake schema and extended star schema. So just simply, I will add one more table here. I can say this is either attributes or properties table for the variant or of the variant. So I can say this one as, it should point to the variant. The same way we can maintain that for the entity also you can maintain one more extension, sub-region you can maintain one more extension, date you can maintain one more extension, and customer table also you can maintain one more extension. Only for the attributes, of course, in SAP data warehouse, there is a concept that you can maintain the test data. For the test, you can maintain separate table. So this is, you can say, test, and this is, you can say, hierarchy. In SAP BW system or in SAP data warehouse, you can see these many tables are connected to your master key. So this one is hierarchy, this is the test, this is the attributes. Test in the sense, say suppose this is the key, right? You can call it as in different terms by like short test, medium test, and long test. So all the test we are separating as the one table, and if it is having any hierarchies, all the hierarchy data I maintain in one table, and its attributes I maintain in one table, The master key, I maintain one table. This master key connected with the hierarchy, attributes, and the test. Now this master key connected with the transaction table. So that's why this star schema now becomes the extended star schema. Of course, whatever the schemas we design, all these schemas are generally we use to read the data, to improve the performance, to read the reading capability, simply we can say. Okay, once you understand this star schema and snowflake schema, then we can understand easily that when to use the data in the data builder. Especially in the data builder, you can see there are different objects in the data builder. Here you can see in the data builder, new table, graphical view, of course it is graphical view, SQL view, entity relationship. You can see here the snowflake, sorry, the name itself is showing, right? I mean, new entity relationship model, it is showing like a star schema, right? New analytic model, it is the dimension or extended star schema, you can say. Generally, all the dimension modelings, we can say extended star schema, we say. And replication flow, these are all the just flows like joining the tables from the build one table to the another table, or new table to the entity relationship tables, like that. These are all a new task chain. This is the job running. Intelligent lookup, we can discuss of every object and its functionality, whether it follows the star schema or whether it follows the extended star schema. Okay, not only this, we can discuss of how this data sphere can be connected to the analytics model in the coming sessions. You can see here data sphere directly connected to the analytics cloud for the analysis purpose. In my previous videos, I have told you about the analytics cloud, where you can maintain the planning and analytics. So you can use DataSphere to analyze your data set using the analytics cloud. Of course, you can use analytics cloud for the planning purpose also. And of course, you can use this data. I mean, you can use this DWC or DataSphere as the source for your Power BI or the Tableau or any other reporting tools. Okay, in the coming sessions, I will start with new table and its functionalities, how to load the data into this table, what are the source systems. But as I said, like it is the trial version I am using. I use only the flat files as the source to show you the how behavior of the data sphere. Okay, thank you for watching. Uh, I will welcome your suggestions, and if anything I missed, please let me know. I will add them in my previous, I mean, in my upcoming videos. Thank you.